Welcome back to Space Repo, your number one source for all things cosmic and cutting edge. Today, we're diving deep into the universe through the golden eyes of the James Webb Space Telescope. In just a short time, this incredible observatory has delivered images and data so profound, so unexpected, that they are forcing astronomers to question long-held theories about the very origins of our universe. From galaxies that seem impossibly old to the secrets hidden in the atmospheres of distant worlds, the cosmos is proving to be far stranger and more magnificent than we ever imagined. We're breaking down the top 5 discoveries from the JWST that are forcing scientists to grab their textbooks and start rewriting the history of the Big Bang. So, strap in as we journey to the dawn of time and explore the findings that are shaking the very foundations of astronomy. Let's begin with our first game-changing discovery, the impossible early galaxies. For decades, the standard model of cosmology, known as lambda CDM, has given us a clear timeline for the universe's evolution. It predicted a gradual, slow-building process after the Big Bang, where small, wispy clouds of gas and dust would slowly coalesce over hundreds of millions of years to form the first stars and, eventually, the first small, irregular galaxies. These primordial galaxies were thought to be chaotic and small, slowly merging and growing over cosmic eons to become the grand, structured spirals and ellipticals we see in the local universe today. But the JWST took one look at the early universe and showed us something completely different, something that, according to our models, simply shouldn't exist. The telescope peered back over 13.5 billion years, to a time when the universe was just a toddler, a mere 300 to 500 million years old. And there, in the faint, red-shifted light from the cosmic dawn, it found them massive, well-formed, and surprisingly mature galaxies. These weren't the small, clumpy proto-galaxies astronomers expected. Instead, JWST revealed galaxies that were already teeming with stars, some possibly as massive as our own Milky Way. One such object, known as galaxy C13, was spotted at a time when the universe was only 330 million years old. Finding a galaxy this substantial, this early on, is like finding a fully grown redwood tree just a few weeks after the first seed was planted. It fundamentally challenges our understanding of galaxy formation. The established models simply don't have enough time built into them for such large structures to assemble so quickly. It suggests that the processes of star and galaxy formation in the early universe were far more efficient and rapid than we ever thought possible. Scientists are now scrambling to adjust their simulations, considering possibilities like the direct collapse of massive gas clouds into black holes, which could have seeded these galaxies and accelerated their growth. These impossible galaxies aren't just a curiosity, they're a direct challenge to the timeline of cosmic history as we know it. Moving on to our second groundbreaking discovery, let's talk about the mysterious darkness of Earendel. Before JWST, the Hubble Space Telescope gave us a tantalizing glimpse of the most distant single star ever detected, nicknamed Earendel, which means morning star in Old English. This star's light traveled for 12.9 billion years to reach us, but we could only see it thanks to a cosmic fluke known as gravitational lensing. A massive galaxy cluster sitting between us and Earendel acted like a natural magnifying glass, bending and amplifying the star's faint light thousands of times over. Hubble could see it as a single point of light, but its nature remained a mystery. When JWST turned its powerful infrared gaze upon Earendel, astronomers were hoping to finally unravel its secrets. Based on its incredible brightness and distance, it was theorized to be a population 3 star, the very first generation of stars born from the pure hydrogen and helium of the early universe. These pristine stars were predicted to be exceptionally massive, hundreds of times the mass of our Sun, and incredibly hot and bright. But JWST's observations revealed a surprise. Earendel was indeed a massive star, likely a B-type star more than twice as hot as our Sun and about 1 million times more luminous. However, its color and temperature profile didn't quite fit the extreme characteristics expected of a pristine population 3 star. More intriguingly, JWST's data hinted at the presence of a cooler, redder companion star orbiting Earendel. This discovery is profound because it suggests that even in the very early universe, stars may not have been the solitary giants we imagined. Instead, they might have commonly formed in binary or multiple star systems, just as they do today. The presence of a companion would have significant implications for the evolution and eventual fate of these first-generation stars. The riddle of Arundel's true nature, whether it's a single, supermassive star or a complex system, is far from solved. But JWST has given us the crucial first clues, pushing us to refine our models of the very first stellar nurseries and the lives of the universe's trailblazing stars. The morning star has dawned on a new era of stellar archaeology. For our third discovery, we're shifting our focus from the distant past to the worlds orbiting other stars. The JWST isn't just a time machine, it's also a revolutionary tool for atmospheric analysis, and its first major target, the exoplanet WSP-39b, did not disappoint. WSP-39b is a hot Saturn, a gas giant roughly the size of Saturn but orbiting incredibly close to its star, completing a full orbit in just 4 Earth days. This proximity heats its atmosphere to scorching temperatures, making it an ideal laboratory for studying exoplanet chemistry. Using its incredibly sensitive spectrographs, JWST observed the planet as it passed in front of its star, a technique known as transit spectroscopy. As the starlight filtered through the planet's atmosphere, different molecules absorbed specific wavelengths of light, leaving a unique chemical fingerprint. Previous telescopes, like Hubble and Spitzer, had detected water vapor and sodium, but JWST's data was on another level entirely. It delivered the first-ever definitive detection of carbon dioxide in the atmosphere of an exoplanet. This was a landmark moment in the search for habitable worlds. While WSP-39b itself is far from habitable, the ability to clearly detect carbon dioxide is a critical milestone. On a rocky, Earth-like planet, the presence and abundance of CO2, alongside other gases like methane and water, could be a key indicator of geological or even biological activity. But JWST didn't stop there. Further analysis of the same data revealed a complete and complex atmospheric profile. In a stunning chemical first, astronomers also detected sulfur dioxide. This was a complete surprise, as this molecule is created through photochemical reactions, when starlight breaks apart other molecules in the atmosphere. Its presence implies that the atmosphere of WSP-39b is a dynamic and active chemical factory, constantly being reshaped by the intense radiation from its parent star. This discovery opens a new window into understanding the atmospheric chemistry and climate of alien worlds, bringing us one step closer to identifying planets that might harbor the right conditions for life. Next up, our fourth discovery takes us back to the dawn of time, focusing not on galaxies, but on the supermassive black holes at their centers. A central tenet of modern astrophysics is that galaxies and their central black holes grow up together, in a process called coevolution. The idea is that as a galaxy grows by accumulating gas and merging with other galaxies, its central black hole also grows by feasting on that material. This relationship is so consistent in the modern universe that there's a predictable ratio between the mass of a galaxy's central bulge and the mass of its supermassive black hole. But once again, JWST's observations of the early universe are throwing this neat picture into disarray. The telescope targeted some of the earliest and most distant quasars known. Quasars are intensely luminous galactic cores powered by supermassive black holes actively feeding on surrounding gas and dust. In the process, they release mind-boggling amounts of energy, outshining their entire host galaxy. JWST was able to separate the brilliant light of the quasar from the faint glow of its host galaxy for the first time. The results were astonishing. In several cases, the supermassive black holes were found to be far more massive relative to their host galaxies than what is seen in the local universe. Some of these ancient black holes contained as much as 10% of the total mass of their host galaxy, compared to a mere 0.1% in galaxies like our Milky Way today. These overmassive black holes in the early universe pose a serious chicken and egg problem for astronomers. It suggests that in the cosmic dawn, the supermassive black holes might have grown first, acting as gravitational seeds that then rapidly gathered matter around them to form the first galaxies. This black hole first model is a radical departure from the standard galaxy first theory of coevolution. It forces us to reconsider the fundamental relationship between galaxies and the monstrous objects lurking at their hearts, suggesting the rules of cosmic growth were very different at the beginning of time. Finally, our fifth and perhaps most visually stunning discovery concerns the cosmic building blocks themselves. JWST has given us an unprecedented view of stellar nurseries, the vast clouds of gas and dust where new stars are born. One of the most iconic images released was of the cosmic cliffs in the Carina Nebula, a sprawling star-forming region about 7,600 light-years away. Previous images from Hubble showed this region as a beautiful but opaque wall of gas and dust. But JWST's infrared vision pierces through the obscuring dust, revealing what lies within and behind this cosmic curtain. The result is a breathtaking landscape of star birth, unlike anything we've seen before. The image reveals hundreds of previously hidden, newborn stars, appearing as tiny red dots still embedded in their dusty cocoons. It also shows incredible detail in the structure of the nebula itself. We can see giant bubbles and cavities being carved out by the intense ultraviolet radiation and powerful stellar winds from the massive young stars located just above the field of view. We can see pillars of gas and dust that are resisting this erosion, acting as dense nurseries where the next generation of stars will form. Most excitingly, JWST has revealed jets and outflows shooting out from some of these infant stars. These are the telltale signs of active star formation, where a young star is ejecting material as it accretes mass from its surrounding disk. This single image provides a complete snapshot of the star formation cycle, from the dense, unformed pillars of gas to the newly ignited stars breaking free from their natal clouds. It's not just a pretty picture, it's a treasure trove of data that allows astronomers to study the process of star formation with unparalleled resolution. By counting the number and type of stars and analyzing their distribution, scientists can now test and refine their theories about how star clusters form and how the feedback from massive stars influences the birth of their smaller siblings. The cosmic cliffs have become a new benchmark for understanding our own cosmic origins. From impossibly large galaxies at the dawn of time to the complex chemistry of alien atmospheres, the James Webb Space Telescope has already reshaped our cosmic perspective. We are living in a golden age of astronomy, where every new image and data set has the potential to rewrite textbooks and open up entirely new fields of inquiry. The universe, it seems, is far more complex, dynamic, and surprising than we ever dared to dream. Thanks for joining us on this journey through JWST's most revolutionary discoveries. If you found this as mind-blowing as we did, don't forget to hit that like button and subscribe to Space Repo for more deep dives into the mysteries of our cosmos. Until next time, keep looking up.